Thank you very much, Roman. And Mirjam is going to start.
Yes.
We have agreed upon that.
Okay. Hello, everybody. We are very, very happy to be here and share our research with you. As Roman said, Natasha and me, we are both architects. Natasha is from Ukraine. I'm from Switzerland. We are kind of nowadays experts for circularity topics in Ukraine. And we are going to present you today our report, which we did for the new European Bauhaus. We started last autumn with it, and it is about circularity in the building industry or construction industry. I would like to start here with a slogan which we developed when working on it. It is: the best revenge to our enemies is to rebuild Ukraine as a sustainable and prosperous country using the ruins they have created. Why is circularity so important? A transition to a circular economy in the construction sector is actually the major challenge of our time. It is not for Ukraine, it's a worldwide challenge. The reason is that the construction industry is consuming almost 40% of the resources globally and has a big impact on the carbon emissions. And of course, also creating a lot of waste. So the aim of a circular economy is to use less material, use components as long as possible, use resources as efficient as possible, and close loop for materials and products. No, please back.
Oh, back. Okay.
Yeah, back, please. And why that? I will tell you when we switch. The main idea in the context of Ukraine is, of course, that when it comes to reconstruction, we are not coming back to the pre-war state of how construction industry is done, but actually applying these new principles to it. So making the development sustainable and meeting also the Copenhagen criteria, because the aim is to be for Ukraine to become a member of the European Union. Next slide, please. So circular construction circularity in construction means that, as I said, we should use less materials, use components longer, apply materials where they are recyclable, and of course also apply the principles of biodegradable materials. So the priorities of circularity, is to put it very simple, is to repair, to reuse, to remanufacture, and to recycle. Next slide. Next slide. Or if you want to add something, Natasha, you can. So now it's on Natasha. We will switch all the time.
Добре. Okay. So I would like to emphasize, like Mirjam has said, the major priority in the world from the point of view of circular construction is reconstruction of buildings. Reconstruction of the available buildings and keeping them as they are and prolonging their life. When we focused on this topic in the Ukrainian context, we have analyzed what kind of buildings are available for us and what kind of buildings Ukrainians live in. As such, we don't have official statistics. What we have is when certain types of buildings were built, when their latest renovation was conducted, and we found out that around 40% of Ukrainian families are still living in a mass market Soviet building, which were buildings which were built starting from the 50s of the last century onwards. These were Khrushchevkas and then the improved panel houses. So around 40%, yeah, excuse me, it was not 40, but half half of the population, so 50%, even more than 40, and only 3% are dwelling in pre-war houses, and 40% are living in the so-called private housing sector. And so we don't have a lot of typology, and the serialized houses are constructed within typified series, and they could be, I think, approached with the special approaches. Ukraine is not the only country that has such legacy of mass market housing, and I think the most famous example of the renovation comes from France, and it was done by Pritzker Prize winning architects Lacaton and Vassal. Actually, it was awarded for this project too. What they did was they took a very sad panel-based house and they built a new facade to it using polycarbonate panels, and they made a whole gallery, and this expanded the space of the apartments. Actually, they built verandas, which are rather typical for Ukrainian houses, for traditional Ukrainian peasants' houses in Ukraine. And so verandas would accumulate sunlight, and besides giving additional living space, they also improve thermal characteristics of such houses. This project cannot be used to all of our panel buildings because it has its own special features. For instance, these flats are of low depth, and so when you add the gallery, we keep them insulated enough. But this example can show us that every building can be approached in its own way to be made better. This is an example from Germany, because in Germany we have quite a lot of post-war mass market housing. This used to be a 5-story building which featured 125 absolutely identical flats. During the renovation, it was replanned and it got new galleries attached, and the upper floor got its own penthouse with a terrace, and even such sad buildings can be improved in their architectural qualities, and it is clear that these projects are not cheap and they require architectural planning. And we know that in Ukraine, renovation of multi-story buildings is not conducted just because we don't know how, we don't have any projects. That's not the case. Our research shows that it is not performed because we lack legislation and we have property problems attached to it, but there are architectural approaches, and it is possible to preserve such houses and reuse them. Then we had a look at one-family houses, especially rural houses, which were built after the war starting in the 1950s. This is called a typical rural house of Soviet times. Starting in 1990, around 3,800,000 of people moved from rural areas to cities, and this means that quite a lot of houses, rural houses, stay abandoned, and they can be used to, for instance, house IDPs. Yes, these houses have a lot of drawbacks. They are not energy efficient. Very often they are using asbestos containing materials, mineral cotton wool, rock wool, which is a dangerous material to use in your house. But for this slide, we are also showing the results of the dissertation of one of our colleagues from London Architectural School. Artem Aslanivsky showed that if you invest just a little money, the energy efficiency of such houses can be boosted greatly. So you can see coming from 6.21 watts per square meter, we can reach 3. So we can halve the energy consumption of such a house just by using specific materials for isolating its roof. So these are the changes, alterations are possible for people to do it on their own, and because the materials used include straw, include clay. So these are rather cheap and available and affordable solutions. To move further on, we would like to talk about the reuse not of houses but of the elements, and I would like to give the floor to Mirjam here again.
Yes, thank you, Natasha. Exactly. After talking about possibilities for renovation of existing buildings, we also focused on the potentials for the topic of demolished buildings. So demolished buildings, when we look at that, it's relevant to talk about the reuse of building components and the recycling of building materials. Here, can you go back? Still one. Oh, okay. Okay, I have another order. Sorry, I have another order. Maybe, yes, please this. In my version, I had another order. Okay. So first this and then go back. So looking, of course, a very relevant topic is the reuse of concrete panels. The reason for it is that in Ukraine there is a lot of panel housing existing, so there is a high potential for studying the reuse of it. And in general, looking at other projects in other countries, studies found out that approximately 30% of panels can be reused as a structural element. They have looking at this, of course, a very high reusability potential because they have structural qualities. And it is also, if you can see here in the image, for instance, it is possible to cut them, and already a couple of projects exist where people have applied these panels in single-family houses. Of course, what would be very helpful, please stay on the slide. I tell you when we move. Can you go back? I tell you when you move. What is of course very relevant when we look at the reuse of panels, if we would have a database available, so if we would know how many panels are existing in which buildings, then of course it would be much more easier to reuse them. A challenge when looking at the bigger scale construction, we have the challenge is that they need to undergo tests for their structural quality and of course certification. Next slide, please, or back slide. Here is a study or kind of a case where these panels were used to build 1 or 2 story buildings, and you can see that they have also what they also did for this project. They looked into a certain radius, meaning because by that they could reduce actually the transportation time. Also, and of course they could also save energy. Next slide. After the next, yeah. Yeah. Okay. So this slide is about the reuse of steel and structural components. That's also a very important topic, especially steel is used in the context of industrial construction very often. And it is the reuse of steel is also very relevant because it's a high energy demanding process to produce steel. So that's why the reuse of these structural elements, which are usually very easily assembled and also easily to be disassembled, has a big potential. Of course, also because it has also structural qualities, the steel, it has also, there's also certification needed, but it was tested already in many countries to reuse such kind of beams and structures. For instance, here you can see a project in Norway where they have used almost all in all, including also other materials, almost 80% of materials recycled. Next slide. Next slide. Another aspect when we look at building materials and components is, of course, our bricks. Bricks are usually they are already recycled in Ukraine. Maybe some of you know projects. Most important is that the younger bricks or from the younger times, they don't have so much quality, but the ones from the times before the 70s, they have actually a very good quality. And on that on this slide, you can see two projects applying two possibilities to reuse bricks. On the left-hand side, you can see a project in Denmark, done by Ländler architects, where they have actually not used the single tiles, but they have cut the walls, the brick walls, into pieces and have rearranged them in a building. You can see it by the different colors. On the right-hand side, there's an example which is let's say, demands more handicraft. It is a building which was also done by recycled bricks, but they were used as single pieces. And this project was in Ukraine, actually. Next slide. Besides these two examples, there are, of course, many, many others of the possibilities for recycling components. Here you see three examples. The first one on the left-hand side is an office building in Belgium, where the architects used wooden planks from different buildings. That's why you see the different colors and sizing also. These planks, they were cut in the same length, but they have different width. And this kind of the difference also creates a certain structure and also a certain aesthetics in the facade. But it was kind of applied in a very clever way, with deciding for a maximum length where you could actually then reuse maximum amount of wooden planks. In the middle is an example for interior design, where tiles are used. It's an example from the Netherlands. You can see that kind of in a creative way, the architects have applied this. The panels or the tiles which are still in a good shape, they are used for grid, and the other ones are kind of rearranged in a mosaic. And on the right-hand side is an example from Ukraine, actually, from Ivano-Frankivsk, where our colleagues from MetaLab are working with a lot of recycled materials in their renovation projects. Here you can see the reuse of glass blocks, which were found in the building and then used for renovation in another spot. Next slide, please. Maybe I have again another order.
Прошу вибачення, Мір'ям, я знову змінила так.
Yeah, Mirjam, I have changed the order.
Yeah, I don't. Yeah, Yeah, okay. So I go for that order. So here, another very important topic you might know, or I'm sure you know, is the reuse of windows, or the topic of windows in general. They are at the moment a scarce material in Ukraine. And besides that, the production of glass is a very high energy demanding process. And that's why it's also very interesting to look at the possibilities for recycling. When it comes to the recycling of windows, of course, they have different sizes and they cannot be adjusted very easily because they are coming with a frame. Here are two projects where you can see how you can do this as an architect in an intelligent way. On the left-hand side, you can see again a project from Denmark where you can see that the windows, because they don't meet the energy efficiency standards, of course, the old ones, they have been using the windows in let's say as a double glazing, so that you have a very good energy efficiency standard which you can meet. And then on the right hand side you can see another approach where different windows of different sizes were rearranged in a bigger glass facade. So then please go back to the slide before, or in my version the next slide. So there is actually also examples of the reuse of windows in Ukraine already. This is an initiative from Switzerland where the initiative is gathering windows from construction sites and is sending them to Ukraine, where they are already used in different in a series of renovation projects. Of course, in the first place, maybe it doesn't make so much sense because it's a huge work for transportation and also creates emissions. All in all, the emissions, the carbon emissions, when you look at these, they are still lower. That's interesting. That's the reason. Because the reason is that production of glass is so high energy demanding. But looking at the scarcity at the moment in Ukraine, it's a very important project actually. Okay, now back to Natasha, who will talk about, no, sorry, I have two more. So then, next slide, please. Sorry for the, yeah, okay, so destroyed buildings, yes. So I want to also very shortly talk about the recycling of building materials. We have, of course, also looked at a general approach, what kind of waste is actually generated when debris, when a building is demolished. And looking at Ukraine, it's a data from 2017. One can say that around 80% is concrete and masonry. And the rest is wood, PVC, gypsum, glass, wool. They are pretty low percentage. And looking at this, of course, concrete especially has a very high potential. Next slide. Looking at the debris, especially the debris today, which we have in war times, we have to mention the problem of the hazardous waste. This is a big thing because, of course, usually you have already problems like asbestos, it was already mentioned before, or harmful materials. But now with the situation that the buildings are actually still in use when they are demolished or destroyed, there's also tons of other poisonous material which is mixed in the waste, and that creates a pretty dangerous mix, let's say. And today, when you look at the way to deal with this waste, it's often it's not sorted, but it's just is sent to landfills, and with that, all these substances which are in this debris, they are going to pollute the soil and the groundwater and also the air. This is a ticking time bomb for Ukraine, of course. It's a very dangerous topic, and we think that's why we wanted to really mention this. So we also know that the utilization of hazardous waste is very expensive, and the know-how on how to utilize this waste is not very high and not very spread. Besides that, the knowledge in the society on the harmfulness is also not so high at the moment. And yeah, we see that there's a need to work with this topic. Next slide. Yeah, so talking about asbestos, we think it would be very important that the municipalities would inform the waste pickers and all the people working with the landfill and the debris about that. On the one hand, the risk in direct contact with asbestos are very high. You can create lung cancer and other very uncurable diseases. Then, of course, it would be very important to inform everybody working with the debris in which materials asbestos is normally used, because the testing for asbestos is, of course, a very difficult and time-consuming process. And a very easy and very safe way to protect the people would be that they would wear masks to protect the respiratory system. And of course, it would be also very relevant that during the removal process of the debris, that all the asbestos-containing materials are sorted out. Then looking at the further management of the polluted material, it should be asbestos should be packed in a air closed system, and also stored somewhere so that it can be utilized later on. And of course, it should not be placed in a general landfill, because from that it can go into the air and into the groundwater, and then can even produce a bigger extent of harm. Next slide. Okay, so looking at the recycling of concrete, there's many interesting and cutting-edge technologies developed worldwide. I won't go so deep into it because the time is running. So here you can see the possibility for recycling, and you can see that on the right-hand side, you can see that there are concrete in general is consisting of different materials, and the most relevant one is actually the cement. And besides that, there are nowadays new technologies developing where it is possible during the process of doing the concrete, you can actually store CO2 in the concrete. So you can decarbonate the atmosphere and then store it there, which actually makes a new product which has a positive effect on the society or on the environment, I mean. So next slide is the next slide will be it looks different now again.
Sorry, Mirjam.
What is it about?
Вибачення, Mirjam. Я теж
What is it about?
ще один слайд.
It's about urgent action about reuse and recycling. So maybe I can give a short comment about it. So we know that in March last year, in September last year, the government of Ukraine has adopted the procedure of treatment of demolition debris, and it lists very nicely the categories of possible demolition waste, and we know that there are the hindrances to implement these guidelines. We understand that the key here is lack of funding, but we understand that this procedure is well drafted, and we call you to follow it. The only thing that we are not supporting is that it recommends to take the debris, the waste, to the temporary landfills and only there to sort them out and to recycle. We believe that it is much more efficient to sort and recycle on the spot, because we do have mobile movable equipment, crushers, which could be used for that, and these crushers are produced in Ukraine, and we have at least 2 manufacturers who have the opportunity to supply this. They are not cheap, but they are available, and the crushers, to buy a crusher for big concrete debris, you will have to pay around 1 million euros, but you can rent such things, and you can turn to such companies for rental. And also the sorting and recycling on the spot is more efficient, because when you do this on the spot, the volume of the debris is growing less.
I can continue
here. It is
here.
easier to transport.
I can continue here, I think, because I have prepared for that slide. So, okay, but maybe we are anyway already in 42 minutes. Do you have the example from Finland still in the presentation or not, Natasha? The next slide.
I guess, yes, we have it. We have it.
Okay, maybe very shortly. So, talking about this process, it is very interesting, because there are just recently there's a company in Finland who actually started to do this carbonation of concrete. They are producing precasted elements by carbonizing the concrete, and it is, of course, it will be a big topic in the European Union in the long term, because every country needs to reduce the carbon emissions. So in this, let's say in this industry around the carbonization, there is, of course, a big potential, and we see also big potential for Ukraine if they can take now this chance by reconstructing the country and think a little bit more in the future. They could really also become a player in this field. Okay, now you have the smart crusher still in it? Okay, good. Another cutting edge technology when we talk about the recycling of concrete is the smart crusher. This is, I have mentioned already the importance of cement. You can see these grains on the right-hand side in the end of the slide. The cement is actually the very, very interesting aspect for concrete, and usually it is not possible to extract the cement, but this technology actually makes it possible to extract all the basic components of concrete, which actually makes the recycling of concrete in a very makes it very efficient and very much reusable. So this technology, and maybe we come to the next slide, is actually, and that's a nice thing we found out, is already let's say in the starting on points to be established in Ukraine. There is a professor from Belgium, and they are going to actually introduce this technology in first projects in Ukraine. Okay, now Natasha, is your turn.
Okay.
У вас 5 хвилин, колеги, залишається.
Dear colleagues, you have 5 minutes. Well, then I will be really brief. Very quickly, when we are not using something that we had, but we need to build some new structures, we could be more ecological and circular by using the following materials. So the materials which are biodegradable, biological materials. So these are the materials which we get from plants growing, which could be returned to the cycle of nature. And one of the interesting materials for Ukraine is rye straw. Why rye straw? Because rye straw is not tasty for mice or insects. When people are told about straw houses with the straw walls, the first question is, oh, mice will eat it. But mice do not eat rye straw. And so besides such buildings are constructed in Ukraine, we already have around 100 private straw houses built using this technology. The construction is really swift because these panels are manufactured on the industrial scale, and they are swiftly manufactured. And simply these are assembled houses, like we assemble houses from concrete panels, precast panels. We are doing the same from straw panels of pressed straw, which has a very high fire resistant class. So it is not burning. It is smoldering very, very slowly, and it is certified. At present, our legislation doesn't allow us to erect houses higher than 3 floors using straw, but if you use the hybrid approach, that is, you combine, say, concrete structure and straw walls, you can make it higher than 3 floors. And this straw technology is used mostly by companies who are building one single-family houses, but also we have examples of 15 apartment, 2-layered house planned in the Kyiv region. And for you not to believe that we insist upon using straw only in Ukraine, no. Europe also embraces this tendency, and for instance, this house is built in Geneva. It has a concrete structure and straw walls, and inside they are plastered with clay. The house is A+ class of energy efficiency. Another thing interesting about this house is that it is a housing cooperative and actually built by the residents. This is another example from Switzerland, and here it combines reused steel, reused concrete, and also newly produced straw panels which are plastered with clay. And another interesting material is hemp, and it is also grown in Ukraine, not to the large extent because the legislation prevents it, but hemp can be used for making hemp concrete, and this mixture of lime and hemp can be used to cast in situ the walls. It is a brilliant material for thermal insulation. And in the middle, you can see the photo from the webinar, which was conducted in Lviv region. And this is the house for IDPs. So hemp and lime. Here is an example from Italy. Again, this house has a concrete structure, and the walls are made from hemp and lime. Timber clearly is a good construction material, good circular material, but even before the war, we had a certain deficit of resources of timber. In many regions, we had few forested areas, and so if in the future we are building only from timber, we will not grow it fast enough. So our idea is to use timber only when it is necessary. For instance, today we have very popular technology of CLT and LVL beams. CLT is cross-laminated timber, or, well, a glue lam timber, and these are composite timber materials. We have a plant producing them in Ukraine, but it is rather expensive, and the structures, of course, would be well, approximately 1.5 times more expensive than concrete constructions, and so it would be rather expensive to use it in as structural elements, though it is very interesting, of course. And traditionally we built a lot from concrete, and many people are now saying that, well, we must embrace only cast in situ concrete because in the future, because the houses must sustain missile strikes. But yeah, we will have to embrace it. Yet our idea is that concrete is not ecological. Concrete pollutes the environment, being responsible for 8% of carbon exhausts, and so we must reduce concrete usage as to the minimum. And or if we're using such structure, then we must ensure that they are long living. For instance, if the house is morally aged, then we can substitute everything but the bearing concrete structure. For instance, you can see it here. The bearing construction structural frame is built of concrete, and then it is filled with living modules, like books on a bookshelf. And this is a very interesting project in which the concrete is used only for the foundation and one wall in the middle, and the rest is done in steel. The slabs here will be made of concrete, but also it is used together with the metal formwork, and so it minimizes the use of concrete. And this is my last slide. And very quickly, to summarize what we have found out during this research, the major conclusion is that the large amount of waste in Ukraine now can stimulate recycling of these waste, and it can stimulate investment into infrastructure, into transfer of know-how from the European Union countries, and also it can stimulate Ukrainian construction to become a laboratory, not only for Ukraine, but for Europe and the whole world. And because we have enough research that has been done, we have technologies, the only thing we need to do is to use it. And another thing, in Ukrainian construction, we have mostly small and medium-sized businesses, so for them it is easier to embrace circular economy, and this also is a potential. Thank you. And the last phrase, can I say it? Thank you. Yes, you may. I would like to say that as a Rosquit coalition member, I can see that European companies try to start pilot projects in Ukraine focusing on circularity, and Mirjam and me are preparing such project supporting companies from Denmark, from Norway. And so this is not hopeless.
Yeah, maybe
good.
Maybe
Yes?
can I add two more sentences to it, just kind of addressing you as representatives from the municipalities. Of course, it's very clear when you listen to this, it's very clear that investments are needed. It's not like that you can come up with concepts very easily. But it is also, hopefully, it became clear that the funding which will come from outside will be most probably also tied to principles of circularity. So under that aspect, it also makes a lot of sense to prepare for circularity and sustainability in reconstruction. And looking at the building industry, there are, let's say, you can say there are three key stakeholders for it. On the one hand, there are, of course, the policymakers, then there are the investors and the developers. And municipalities, they actually, you have a double role, one can say. On the one hand, you do policies, so you can influence policies in this direction. And on the other hand, you can also invest in public infrastructure, for instance, and also there you can actually become investors. So you are kind of powerful, you have a powerful position to make this shift happen.